现在时间到了，我们开会。
Well, it's about time. Let's get started. Mr. Kakudo, dear experts, dear participants, our colleagues and the Secretariat, ladies and gentlemen, greetings. Welcome to the webinar on nuclear energy and carbon neutrality. I'm Qin Zhijun from National Energy Administration of China. I'm now the vice chair of the steering group and also the co-chair of the NSCCEG. And today, I'm very happy to be here with the other two co-chairs. That's Mr. DeLucci from Argentina. He is not here for some other commitments, but Mr. Kakudo is here. I'm very happy that we can be here for the discussion on the hotspot issue of the challenges and opportunities of nuclear power in the context of nuclear power. I'd like to say a big thank you to the steering group and secretariat of IFNEC for putting this together. And I'd also like to thank all of you for making the time to be here. IFNEC is an important multilateral mechanism in the global nuclear community. Over the past 10 years, it has made important contributions to non-proliferation and global nuclear power development, setting up a bridge for strengthening exchanges and cooperation amongst its members. And over the past years, our working group has organized many forms of activities on nuclear power financing, SMRs, and new builds, doing our part to facilitate nuclear power development across the world. And today's webinar is an important event in the program of work of our working group over the past years in order to fight climate change and facilitate green and low carbon energy transition. Many countries have developed carbon neutrality targets and starting to phase out fossil fuels and are developing renewables such as wind, PV, and hydro power. But these renewables are very vulnerable to climate impacts, leading to unstable energy supply. We have seen many global energy crises over the past years, which has sent out a message to us. We know that energy transition cannot happen overnight, and the complete replacement of fossil fuel will be a long and uphill battle. So we need to tap into the full potentials and different technological, economical, and environmental features of different energy sources, combine their strengths together in an optimized energy mix to improve the quality and efficiency of the entire energy system. In this connection, nuclear power as a stable, reliable, clean and low carbon energy has huge potentials and should play a bigger role in solving energy supply issues for humanity. So through today's webinar, we hope we can exchange ideas on the long-term development or future development of nuclear power in the context of carbon neutrality. So today we have 4 items on the agenda. We'll start with the welcoming remarks of the co-chairs, which will be followed by presentations by our invited experts. And then we will have a Q&A session, which will be followed by some closing remarks by Mr. Kakudo. So throughout the webinar, if you have any questions or if you want to interact with the experts or the co-chairs, you can type in your questions or comments in the Q&A function of Zoom. We will try to cover your questions during the Q&A session. So you may want to specify who you want to direct your question to, so that we will ask the experts or co-chairs to answer your question. We may not be able to cover all the questions, but we will try to cover some of the common issues. Now, without further ado, let me turn it over to Mr. Kakudo for his opening remarks.
Thank you, Mr. King. And can everyone hear me? Okay, thank you. Yes, my name is Takafumi Kakudo, Deputy Director General at the Cabinet Office of Japan. I have been the co-chair of the IFNEC NSCCEG since 2020. First of all, I would like to thank all participants in this webinar from various countries around the world. I would also like to thank the panelists for taking time out of their very busy schedule to speak at this webinar. Thank you very much. Today, the global warming is the most critical issue for the human being to overcome. And at the COP26 in last November, a consensus was built to maintain the effort to achieve the 1.5 degree target. This should be also an opportunity for new growth and create an effective cycle of the economy and the environment. Furthermore, the unprecedented supply shortage of natural gas caused by the current world situation has made energy security issue be a common global issue. We think one of important options that could be taken to achieve these policy objectives is nuclear power. Here, advantages of nuclear energy are as follows. Firstly, no greenhouse gas is not emitted during the power generation process. Secondly, little fluctuations in the output of electricity due to weather conditions and other factors. Thirdly, it realizes carbon-free hydrogen production and prospects for heat utilization. On the other hand, there are several challenges. Firstly, it is critically important to rebuild public trust, especially in Japan. Secondly, enhancing safety and pursuing security are needed. Thirdly, also addressing back-end issues such as decommissioning and radioactive waste disposal are required. Fourthly, in order to solve those challenges, it is necessary to strengthen human resources, technology, and industrial infrastructure at higher levels for continued use of nuclear energy. The IFNEC mission is to provide an opportunity for cooperation to ensure the use of nuclear energy for peaceful purposes, which meet the highest standards of safety, security, and non-proliferation. NSCCEG, one of the working groups of IFNEC, seeks to analyze the current situation and relationship between supplier and customer countries, and set up a reliable and trustworthy discussion environment in order to propose actions. This webinar will discuss the role of nuclear energy in the context of reaching the carbon neutrality, the synergies between nuclear energy and renewables, as well as the multi-purpose application of nuclear energy. And I believe this webinar will become very interesting one. We look forward to lively discussions with all participants. Thank you very much.
好，非常感谢觉道先生啊。
Thank you very much, Mr. Kakudo, for your remarks. So you covered many of the issues that we're faced with in developing nuclear power. Now let's move on to the second item of the agenda, or presentations. we will address all your questions, from the participants after all the 4 presentations. The first presenter will be Mr. Michael Barthélemy, and he will be talking about the role of nuclear energy in meeting climate change targets. And he is a nuclear energy analyst of the Nuclear Technology and Economics Division of the NEA. And he has many international projects, including reducing G3 costs, SMR, and nuclear fuel research. Now, let me give the floor to Mr. Barthélemy for his presentation. Over to you.
Good morning, and thank you very much, Mr. King, for your remarks. It's a great pleasure for me to be speaking at this IFNEC webinar today. As you know, the NEA serves as a technical secretariat for IFNEC, but in addition, we have opportunities for substantive work together, including over the last year and a half on nuclear financing, and today to discuss more broadly speaking the role of nuclear in climate change targets. In my remarks today, I'm going to focus on the presentation report we've published a couple of months ago, which is very much the first report where NEA conducts its own analysis on what could be the potential role of nuclear toward meeting net zero targets. Provide you with a bit of context, then I will focus on key findings in the report, and then discuss some opportunity and challenges as well as recommendation. So nuclear energy in today's energy policy context. If we go on the next slide, I want to start by reminding everyone about how daunting the challenge of addressing climate change is, and how limited time there is today to get us on a path that will mean achieving the objective of the Paris Agreement to limit CO2 emissions in the coming decades is. In particular, if we think about CO2 emission as having a carbon budget above which we would exceed global warming above 1.5 degrees C. In practical terms, that means that we only have 8 years at current emission level until we have exhausted this budget. So there is very limited room to maneuver. There is no time to waste, and it is very much one of the greatest challenges ahead of us. So how do we get there? Go on the next slide. There's a number of pathways that have been published by a number of institutions, including partners of the NEA, such as the IEA. And all these pathways are based on this carbon budget we have to deal with. And they provide different strategies for how we can be on track with this objective, which then translate in many cases in terms of reaching net zero by 2050. First, it's important to note that all these pathways include some level of nuclear energy. On average, we see in many scenarios that would mean at least a doubling of nuclear installed capacity between today and 2050. But what we also see is that whilst for some technologies, there are very aspirational deployments, in particular showing on this table here when we look at, for instance, hydrogen, CCUS, renewables, a lot of the hypotheses underlying these models are very much aspirational regarding what technologies could do in the coming decades. When it comes to nuclear, these pathways tend to be grounded in conservativeness. And what I mean by that is they tend to rely essentially on technologies we have today, which means large-scale Gen 3 nuclear power plant and the existing nuclear fleet. And they give little representation to the role of nuclear innovation, to the possibility of addressing new applications with nuclear energy. And for us, this is very much a gap, because then all of this information leads to advice to policymakers. And if we don't provide representation of the role of nuclear innovation and the role of different nuclear applications, maybe the policymakers don't get the full picture about what nuclear could do in their climate strategies. So if we go on the next slide, and the next one, what we wanted to do in this NEA exercise was to really start to unpack what could be the full potential role of nuclear to contribute to emissions reductions. And that means breaking down nuclear into several blocks, starting with long-term operation, large-scale Gen 3 reactors that we are deploying today, and then innovative nuclear technologies with small modular reactors, and new applications of the use of nuclear energy with non-electric applications such as heat for industry, for district heating, and hydrogen. And what's important to note here is that for us, when we look at these different technologies and applications, we see them as very much complementary and not competing. Going on the next slide. Because time is limited, I'm going to jump straight to the result and our key findings. You will have more of the detail in the report. Our key finding was that when looking at conservative and aspirational projection for nuclear energy in these different blocks, long-term operation, large-scale new build, SMR, both electric and non-electric application, we see that nuclear installed capacity could reach by 2050 nearly 1,200 gigawatt electric compared to about 400 today. So it's nearly it is a tripling of installed nuclear capacity. And what's interesting, you can see on this slide, on this graph, is that in fact, when we look at what the IPCC says in its summary report, is that on average scenarios, world climate change mitigation scenarios will require a tripling of installed nuclear capacity. And it's very much a coincidence that we indeed show that one of these key conclusions of the average of scenarios that the IPCC is looking at might well be within reach if we can really rely on all nuclear technologies and applications. Moving on to the next slide. However, there's a number of opportunities or challenges for us to get there. When we really limit our exercise to what is currently either in operation or under construction or plan, we see that starting in the 2030s, there is currently a growing nuclear capacity gap. And which then translate in very much some urgency for taking action today. And of course, when there's a challenge here is that one needs to translate to policymakers that they need to take action now, and that if they don't take but if they don't take action now, they won't really realize before the coming decade that they're not on the trajectory that will be compatible with meeting climate scenarios for nuclear. Moving on to the next slide. We identified in the report a number of key challenges, and I won't really list all of them in the interest of time, and I will either really focus on one of them on the next slide, which from the work that NEA has done over the last few years, we really see as the most significant. If we go on the next slide, and that is understanding really what is the cost and competitiveness of nuclear power in such net zero scenarios where we're going to have large scale of renewables in any cases. And it's important and central to this because a lot of the conversation today still rely on plant level analysis of the cost of different technologies, nuclear, renewables, and only looking at the plant level cost we see that as becoming an increasing challenge when we are in a world with viable renewables, because there's a number of costs occurring at the system level related to integrating viable renewables, related to managing the grid, related to getting more margins for your systems with more intermittency of the renewables, and all these costs, as we have higher shares of renewables, become increasingly significant. You can see that on the figure here, which I will briefly comment. It's a 3D graph which shows you different shares of nuclear and renewables on one axis, different level of carbon constraint, and different level of prices of and the resulting prices of electricity in the vertical axis. And what you can see is that a pathway where you only need to reduce your carbon intensity to 50 grams per kilowatt hours may be feasible from a cost perspective with large scale, with mostly renewables and without nuclear. There's going to be a cost premium. It is going to be somewhat significant, but maybe that's a premium citizens, countries are willing to pay. The problem is that if we want to go to net zero, what our analysis shows is that the costs become almost cost curve, because almost exponential, and you will end up on in a world where you won't be on the feasible path to reach your net zero goal. So really, we see that as critical for understanding what will be the competitiveness of nuclear in the future. Moving on to the next slide to conclude briefly with some recommendations from this study and these findings. The first one, as I said already, is very much on the urgency of action. And this is something for both government and industry that have to come together to address this challenge and demonstrate that we can commercially deploy nuclear energy innovations at scale. First is on addressing these timelines, because there is clearly some issue with providing the right timeline for taking action on climate. Sometimes, one may hear the argument that, nuclear power plants have too long construction time. The lead time might not be compatible of nuclear projects with the urgency of taking action on climate. Well, if you take a step back, and you can see that on the graph on this slide, you see that actually, taking a historical perspective, we see that nuclear is actually a technology if you get a programmatic approach and you start building a fleet of nuclear reactors, is a technology that can unlock the largest, the fastest deployment per unit of capital. So we know that nuclear can do it. We know, in fact, that you could do it historically, but also we see they can do it today, looking at the UAE in particular, the Background project. We also see, of course, that China is building multiple reactors with strong lead time. So that's, these are all encouraging signs that there is a way for nuclear to be deployed at scale in a way that will be compatible, therefore, with climate timelines. Moving on the next slide, and this will be my last slide, few additional recommendations. First, on the importance of understanding and reducing cost, and this is something on which INEA has done extensive work at the system level, but also at the plant level, in particular for OECD countries, providing practical advice for governments and industry on how we can reduce the construction costs of large-scale Gen 3 reactors, and our study shows that there is a significant opportunity in the coming decades to do so in OECD countries. Of course, this is not something that the industry or the government can do on their own, and there is very much a sense that this has to be a joint effort. And public confidence, maintaining high level of public confidence and trust is also equally important in our eyes. And I will finish with one last point, which is on financing, where we see really that, if the other points are addressed, it is a significant challenge that has to be tackled, including the role of nuclear in taxonomy and ESG, among other themes, all of which we will have the opportunity to come back, I'm sure, in other IFNEC webinars. So with that, it concludes my remarks. And again, thank you for the opportunity. And I look forward to the questions and discussion afterward.
好，谢谢那个巴特勒尼先生啊，刚才您讲。
Thank you very much, Michelle. Your speech is not long, but your analysis is very deep and very concrete. Thank you. Next, I want to give the floor to the second speaker, Richie Van Peek, and her speak is the potential of nuclear replacing fossil fuel. Actually, Madam Peek worked for IAEA. He is leading the Energy Economics and Environment Unit, Planning and Economics Study Session, Division of Planning, Information and Knowledge Management, Department of Nuclear Energy, IAEA. Well, she will talk about the role of nuclear power, particularly with the higher and higher share of renewables. The floor is yours.
Okay, thank you, Mr. Chin, to give me the floor. So I will tell a bit about nuclear energy's potential to replace fossil fuels, mainly based on some recent work of our agency, International Atomic Energy Agency. So next slide, please. Okay. So I want to use our publication, Nuclear Energy for a Net Zero World, as a basis for my talk today. Among other topics, how to move away from coal and how to decarbonize energy systems were discussed in this publication of 2021, so last year. So some selected messages are nuclear power plants are well suited to replace coal-fired power plants for low emissions electricity generation. Nuclear power can also substitute coal-fired boilers for district heating and industry. Nuclear energy can provide low-carbon hydrogen for hard-to-abate sectors via both established and emerging production processes. Next one, please. So a brief outline of my presentation. I will talk first about the energy consumption. So what's the demand? Then the replacement potential of nuclear power. Then how to move away from coal, and then replacing the other fossil fuels with hydrogen. Next one, please. So when looking at the world's final energy consumption, we can see in the figure on the left that the world is still fossil fueled for more than 60%, about 2/3. And looking at the economic sectors, we see the greenhouse gas emissions, that's on the right, are for 60% in the energy sector, only 22% in electricity. So all the rest is non-electrical. So that's also a potential in the energy sector. Next one, please. So like the previous speaker already mentioned, the climate change mitigation is urgent. So when we're looking at how to replace coal with nuclear, then it's wise to look at those countries first that already have nuclear programs existing or are already engaged in starting up new nuclear programs. So in the graph, you see first these 32 countries that already have the existing nuclear programs existing, and on the right there is a few countries with new nuclear programs. And this graph shows their energy mix and their electricity generating mix of 2018. But so there's among either the 32 countries currently operating nuclear power plants. And there's 10 countries that have decided to include nuclear energy in their generation mix with plants under construction or in advanced stages of preparation. And there are several of the countries that are most dependent on coal for the electricity generation. You see on the right, coal is on the red. So we see, for instance, South Africa, India, China, Czech Republic. They're very much dependent on coal, although the other also have nuclear power in their energy mix. Nuclear is the light blue bars. And So these countries do not only have the experience in the infrastructure, such as the regulatory framework in place to support a relatively rapid switch from coal to nuclear energy, but also account for around 85% of the world's coal generation. And most of this is produced on a scale that is well matched to the output of one or more large nuclear power plants. Replacing just 1 percentage point of this coal generation with nuclear power would reduce the annual emissions by around 100 megatons of CO2, requiring about 12.5 gigawatts of nuclear capacity. Likewise, replacing 20% with 250 gigawatts of nuclear generation would reduce emissions by 2 gigatons of CO2, or around 15% of coal power sector emissions. So this is an opportunity that is relatively rapid because these programs are already in place, already under construction. But nuclear can also contribute to climate change mitigation beyond the electricity generation. And the next slide shows an example of this. Next one. So this is the Temelín nuclear power plant in the Czech Republic, which has a heat distribution system, which has been extended to the town of Tinatlavu. I hope I can pronounce it well. And this helped to eliminate 22 medium-sized coal-fired boilers that were heating plants that have these boilers, and 3 large boiler facilities with this nuclear facility. So that also helped to clean the air in this region a lot. And recently, this construction has been started, as you can see on this photograph, to extend this distribution system, the heat distribution system, to the town of the České Budějovice, is well known for the famous brewery of the Budweiser beer. And this will supply heat to 30,000 inhabitants and contribute to about 1/3 of the city's total heat supply. And it will save about 80 kilotons of CO2 each year for at least 30 years. So which nuclear technologies could be available to replace these fossil fuels? That's on the next slide. So we have been categorizing the nuclear technologies for replacing coal into 4. The existing water-cooled technologies is the first category, of course, but there are 3 other ones with the small modular reactors. And whereas the large water-cooled reactors, they can provide electricity and low temperature heat. And they could replace the coal as a multi-unit power plant, and it is a mature technology, and there are more than 300 units in operation. And then there are 3 categories of small modular reactors: the water-cooled ones, and small modular reactors, which are advanced technology. They usually have different cooling media, like helium gas or sodium. And then there are the advanced small modular reactors that will even need some more time for development, with salt or lead cooling. And also there's this version of the very small ones, the micro reactors. The additional advantage with regard to climate change mitigation of the latter 2 categories, that they can also provide higher temperatures. So then engage in more markets, more demand sectors of the industry that are requiring these higher temperatures. That is this 3rd blue column. High temperature heat, 600 to 700 degrees C. That's both for industry and hydrogen production with higher efficiency. And in the left 2 columns, it tells about the coal replacement applications. So you can do that as a single unit, but and also power, but also cogeneration of heat and power, industrial boiler, and in hydrogen. And on the right, it says the technological maturity. And then you see from top to bottom, the large water-cooled, they're mature, but the very advanced small modular reactors, they're still in the research and development demonstration phase. So their contribution to climate change mitigation is still a little bit further away. Okay. How about then replacing other fossil fuels like oil and gas? Today, many hopes are put in the hydrogen option Next slide, please. So this graph first discusses the potential uses of hydrogen in a low carbon economy. So which is already there. And we have the confidence in the role of hydrogen on the horizontal axis and then the readiness on the vertical axis. And you see the existing uses in green, in refining, in methanol, fertilizer. These are existing uses that are aligned with long-term decarbonization. But there's the larger the dot, the more megatons are demand. There's these options of power storage, steel, shipping, aviation. They're highly likely in large long-term demand. So there's a lot of attention going there now. And the others, the yellow ones, potential role technology options. So that is more further away, high temperature heating, rail and plastics and heating. And then there's some short-term transitional uses, but that still could be quite useful to get the market going, to get this production on a relatively relevant scale going. Co-firing of ammonia or hydrogen or the gas grid blending. Next, yeah. So, but yeah, also nuclear. It has been researched already for decades, and so that's so we concentrate on that in the next slide. Yeah. So see, for instance, this report, agency report that's shown on the right. It is from 1999. So, and it's pretty a lot of information in there. So it has been really researched for a long time. But the question is now how to connect to the reality of utilities with operating nuclear power plants. And that's why we started this activity as nuclear agency to connect to existing utilities and chart 10 nuclear power plant projects with hydrogen generation. That starts with looking at the electrolyzers, having small projects on to start this hydrogen production with their existing nuclear power plants. This graph indicates the location and the countries that are engaging in these projects, both in North America and Russia and in Europe. Yeah, next one. So this is then looking again at the uses, but now for the nuclear, these currently nuclear operating plants, what uses they're looking at. And interesting is that they're first of all, that's where they're starting it in the first place, to look at the self-hydrogen consumption. That's the use at the nuclear power plants. And so that can be both during the nuclear power plant construction, that they have equipment and even transportation means like buses running on hydrogen, and then also the power generation that they produce that to export it from the plant and the plant with a gas grid. And so then these utilities are then looking and already producing for a current hydrogen demand. It can be oil and gas refining. It can be ammonia for agriculture. And it can be the industrial gases, like industrial gases company that they're delivering this. And then it's not only hydrogen, but also the oxygen, interestingly. The future hydrogen demand includes then the transport, steel production, and power generation by fuel cells. Next one, that's the final slide. So looking at some differences and some outputs of this hydrogen project. We observe several project differences in search for the markets. Each utility targets different demands, but faces all the time the same challenge of finding a market where they can secure the reliable revenue stream for their hydrogen development projects. There's no winning electrolyzer technology yet. There's different technologies are selected, and so there's no clearly defined superior technology yet. And then the location, and there's still the discussion whether to put that near the nuclear power plant or near the user facility, the hydrogen demand facilities. And so when hydrogen is used primarily in the nuclear power plant, of course, it's then put near the nuclear power plant. but it's only as a step to the commercial hydrogen production. And of course, when there's a large demand facility, then the electrolyzer will be put near that location and the electricity will be transported there. But like the previous speaker already mentioned, the government support is essential to such as government funding, inclusion in national hydrogen strategies. It is key to the nuclear hydrogen production process. And with this, I want to conclude my presentation and I'm open to questions.
好，非常感谢黑客女士。刚才您讲
Thank you very much, Madam Heek, for your remarks on hydrogen production. It is a priority for us. We are very much interested in the pathways, different pathways that we are making, doing our own research on that. Thank you very much. Now, let's give the floor to our third speaker, Mr. Tian Ling, who will be talking about the new roles, scenes, and challenges for nuclear power in the context of carbon neutrality. So he is the head of the Department of Planning and Development of STURDY, and he's been doing policy research and development and planning for over 11 years, and he's also very experienced in international exchanges and collaboration as well. Now, let me turn it over to Mr. Tianling.
Thank you, Chairman. Thank you for your introduction. And I'm Lin Tian from STURDY. It's really a great honor for me to take part in the discussion of carbon neutrality. So today I'd like to share my opinions about those scenarios and challenges for nuclear. So next slide, please. Next. Thank you. So we know in order to reach the Paris Agreement, which have set up the goal for us, especially to reach the global peaking of greenhouse gas emission as soon as possible, is a great challenge for all countries. Up to now, there are the top 10 economics. The top 10 economics has pledged to reach the net zero emission, and especially for China, we have committed to achieve carbon emission peak in 2030, and also make every effort we can to reach carbon neutrality in 2060. So simultaneously, we also put forward the pathway. Just in the opening remarks provided by Ms. Qin, he has said the government has put forward the new energy power system. So from the graph, we can see that compared with other technologies, nuclear power just emit 12 g CO2, which is much less than that of carbon. So for us, in order to reach the goal of carbon neutrality, nuclear is a preferred option. Next slide, please. Traditionally, we know the carbon provided many energies for different scenarios, including electricity, traffic, heating, process steam, and others. But in the context of carbon neutrality, carbon is not a preferred option. So we focus on the development of renewable energy. So for the past years, we all know that the installed capacity of renewable energy has increased a lot in China. But on the other side, its inherent disadvantage, such as random, intermittent, and seasonal, and also it brings great challenge to the grid stability. And in order to support the renewable energy system, we have to spend lots of money on energy storage. So on one side, the renewable energy could provide part of the electricity supply, but on the other side, it could not provide heating directly. So for nuclear, in this new scenario, if we want to decarbonize the electricity system, in this scenario, nuclear energy will be preferred because it is low carbon and also stable, and more importantly, reliable. Next slide, please. So just now, Ms. Hick has said that different technologies of nuclear power could play different roles. So for us, we think in the new system, nuclear power could not only provide electricity, but also heating, steam, desalination, and hydrogen. More importantly, for heavy industry and also for some load centers, which could be its electricity demand could be satisfied by the macro power grid, which the large unit will be constructed near the load center. And for areas with intensive energy use, districts in urban or rural, and data centers, we could provide the SMR to satisfy the electricity demand. Next slide. So what kind of policies or pathways are we going to choose depends on demand and resources and also capabilities. So this is a proposed deployment suggestion from our point of view. For northeast part of China, which is very cold in winter. So we think the SMR could be used to replace the existing thermal plants. And for the coastal provinces, including Shandong, Zhejiang, Guangdong, Guangxi, for these areas, nuclear power should, the large-scale nuclear power plant should be constructed to satisfy the electricity demand. And as we know, the first nuclear heating project has been realized in Shandong Haiyang. So for the past 2 years, it has realized the zero carbon emission for winter heating supply. And for the southwest and the northwest of China, as we know that the government has put forward the large-scale renewable basement, but simultaneously we have to construct the fossil plant in order to make the renewable energy transmitted to other areas. So we think for this scenario, the SMR could be constructed in these areas. So the relationship between renewable and nuclear power is not, they don't compete with each other. More importantly, they cooperate with each other. And for another scenarios, such as an island of grid mode, the nuclear SMR could be constructed and working as the energy center to provide electricity and also desalination and cooling. Next slide. Also, we have seen the future of nuclear power in the context of nuclear neutrality, but there are lots of challenges in front of us. So these concerns are from the stakeholders and what kind of mechanisms should be established to make it happen. So for politics, the regulation of SMR, just at the very beginning, Mr. Michel has put forward a similar opinion. So we know for the traditional large-scale unit, the regulation and the review process is very, very time-consuming. So this is a challenge in front of us. And more importantly, we should play the nuclear power and other renewable energies on the same playground. That's to say, they should, it is green, but it's not, the nuclear electricity is green, but the carbon trade mode does not include the nuclear power up to now. And also, what kind of financing mechanism should be established to support the long-term R&D process and also the long-term construction period. So we need to innovate in the commercial cooperation mode. And more importantly, in the society price, just in the very beginning, Michelle also said, we should not only take part in the plant price into consideration, but also the grid price and the society price into consideration. So what kind of mechanism could be established? We know for different countries, they have different challenges and different challenges. So it's not an easy task. And also the public perception, the good neighbor is also very important, especially after Fukushima. How could we work together to establish the confidence of public in nuclear? And more importantly, it's technology. What kind of innovation could we do to increase the safety level and to increase the capability of nuclear power for the new grid system, such as the peak load regulating, the frequency modulation, load follow. It's different from the traditional. Although for AP1000 and CAP 1400, we have taken the load follow into consideration, but with the increase of the installed capacity of renewable energy, this kind of requirement, this kind of demand has increased a lot. And refilling period, also the automation, and how do we increase the efficiency of nuclear power is also a concern. And we all said that nuclear could be used to generate hydrogen, but on the other side, there are many experts say if we could transmit the electricity to other areas, why do we still need to generate hydrogen? So there are also lots of opinions on this point. So in the context of carbon neutrality, nuclear power is, I think, is promising, especially in China. But there are lots of challenges in front of us. So thank you.
好，谢谢田林先生啊。
Thank you very much, Mr. Tian. I think now I want to give the floor to the last expert, Mr. Satoru Yasuraoka. Well, he will talk about the new progress in the nuclear sector in Japan. The floor is yours.
Okay, thank you so much. Good morning, good evening, everyone. 大家好，皆さんこんばんは to every wonderful, best and brightest participant. I'm Satoru Yasuraoka at METI Japan, in charge of the nuclear power policy and international collaboration in Japan. So today I'd like to share the latest status on Japanese nuclear power policy in the context of the carbon neutrality. So next slide, please. Okay, so my presentation starts from the Japanese basic policy objective for the carbon neutrality. And as you may know, historically, Japan has highly dependent on fossil fuels for electricity generation, but it is, of course, far from ideal circumstances in terms of the environmental policy or in terms of the energy security policy. So actually, there are a lot of challenging issues for Japan to get breakthrough the current situation. But Japanese government declared last year aims to reduce the greenhouse gas emissions to net zero by 2050. So next please. To achieve carbon neutrality, Japanese government should give a strong incentive for companies to tackle issues on innovation and investment. So for that purpose, government of Japan established very large-scale fund that is called the Green Innovation Fund. So in this policy measure, nuclear power is one of the targeted sectors with high priority. So next, please. And this slide shows the historical records, overview of the electricity production by sources. So one point you can easily see is for the latest 1 decade after Fukushima Daiichi accident, share of the nuclear per share has significantly decreased and mainly substituted by from fossil fuels like coal and gas. So next, please. And this is the latest prospects of energy mix in Japan, published by my Ministry of Economy and Trade and Industry, Japanese government last year. Japan aims to reduce the share of fossil fuels according to this energy mix, practically as much as possible, and expected to be substituted by renewable energy and of course, nuclear. So next, please. And this slide is an interesting quote from IEA's analytics, projected costs of generating electricity by region, including Japan. So this IEA's study gives us one suggestion. The cost of solar power or wind power is a little bit higher than other regions like US and China and European countries. So mainly due to the geographical difficulty or specialty in Japan. So then it seems nuclear power has a cost competitive in Japan, at least in theory. So as you may know, so there's a lot of the challenges and another practical difficulty to get in the public acceptance so far. So next, please. So this is a very simple pie chart from IEA, sorry, back to the slide. Previous one, please. No, previous one. Okay, yes, this one. This is a pie chart from IAEA's database called PLEASE, showing the nuclear production rate is very low, just 7% in 2021. So next, please. And this is a historical trend of the nuclear share. You can see what I explained, significantly decreased after 2011 Fukushima accident. So next, please. So this simple slide shows the current status of Japanese nuclear power plants. Only 10 reactors are restarted right now, and others are in the waiting list, long waiting list. 7 has already passed safety review by the regulatory body, and 10 is still under review, and 9 is not applied yet. So the other one is already decided to decommissioning. So next, please. Yeah, I can skip this slide. This is the detail of the status, the map of the nuclear power plants in Japan. So based on this situation, Japan faced a crisis or balance between electricity supply and demand. It's very, very difficult situation we face. Then last month, Japanese Prime Minister Kishida made remarks on nuclear policy for securing energy security. So next, please. Then Prime Minister declared the government of Japan will make every effort to restart the nuclear power stations and to ensuring the 10 reactors back to online. So next, please. So continue the remarks. The Prime Minister also mentioned the political decision is needed to step forward. And the issues include the long-term operation of existing plant, as well as the consideration of development and construction of the next generation advanced reactors in Japan. So next, please. Then right now, the government of Japan, including METI, of course, has a significant task in nuclear policy. That is speeding up policy discussions among the experts to reach a conclusion on nuclear policy by the end of this year. I mean, by the end of the 2022. So we are in the very exciting, how can I say, hot phase. So next, please. So 1 month just before the remarks, a technical working group under the METI has already published a technology roadmap on the development of advanced reactors. And this slide shows one of the roadmap, a quote from the roadmap for the large types of the light water reactors. But for my little bit disclaimer, please note that this is a very tentative one. We have to dig up more details and more feasibility study. Then timeline can be changed and depending on the owner and operator's plan in the future. But this is kind of the tentative, our prospects of the light water reactors. So next, please. So this is another roadmap for the small modular reactors, SMR. So consisting of 2 cases. One is overseas deployment, and the other case is deployment in Japan. So deployment in Japan case takes a more long lead time due to the kind of the communication with regulatory body, or need to starting from the concept design, basic design. And actually this roadmap introduces other types of reactors also, like a high temperature gas cooled reactor or fast reactors. But sorry, now I abbreviated them for saving time of my presentation. So if you are interested in, you're welcome. You can find the materials on the METI's website. It's available in the public. So next, please. So this slide shows the example of international projects on SMR. One is called Voyager, designed by the New Scale venture company in the US. And Japanese companies like JGC or Nikki and IHI involved in this project. For example, JGC involved in the EPC contractor, or IHI the fabrication of the containment vessel of this project. So another example is the latter one, BWRX 300, jointly developed by the GE Hitachi. The first kind of plant is expected to connected on the grid in 2028 in Canada, I heard, and followed by distributing other regions, including embarking countries or operating countries. So next, please. This slide is an introduction of the elemental technology for safety improvement prepared for the severe accident after the lessons learned of the Fukushima Daiichi nuclear power accident. And some of them are already installed, like this high temperature resistant column seals is already installed in the Kashiwazaki Kariwa nuclear power plant, unit 5 and 6. And the other one is expected to install the future plant, or someone is this accident tolerant fuel is now developing international R&D collaborated with international partners like the US laboratories. So next, please. So then the last but not least, Japanese government also supports non-light water reactors. HTGR, the first one, or helium gas cooled reactor has been developed by JAEA. So and recently announced, as you may know, to start a kind of the feasibility study with UK entities, NLL, supported by the government of UK. And this plant is expected to produce not only electricity, but hydrogen. Hydrogen production by utilizing high temperature heat around 900 degrees Celsius. So this is very interesting technologies to collaborate with other international partners could be. And the other one is a natrium reactor developed by the US-based TerraPower, sodium-cooled fast reactors. And Japanese technology entities like JAEA and Mitsubishi partners are involved in this cutting-edge project. So the Japanese government, especially METI, is very happy and willing to push up these advanced reactors. So next, please. So now I reach a conclusion. So now it's very interesting phases. Prime Minister Kishida remarked nuclear power plant needs to step forward more. So we have to do the consideration like utilization of existing plants, development of advanced reactors. So Japanese private firms or national entities, R&D TSO, has developed varied types of reactors so far, including large light water reactors, SMR, or HTGL fast reactor. So a lot of menus we have. So we will speed up discussion among experts to reach a discussion by the end of this year. So thank you so much for your listening. So next slide, please. If you are interested in say more, so I'm always welcome to your question. Thank you so much. 谢谢您，ありがとうございました。
好谢谢安良这个港务先生。
Thank you very much.
Yeah, this is my Chinese name. Thank you so much.
Yes, indeed.
港务先生呢，这个长期从事这个日本的核电的这个管理，是吧？
So you have lots of experience in management of the nuclear power sector in Japan. Thank you very much for your sharing, and we are very happy to hear the recognition of the Japanese government towards nuclear power. And we hope that nuclear power can play its role in achieving carbon neutrality. Thank you very much again. So now we are getting to the Q&A session. We have collected a couple of questions. First, I think there's a question to Mr. Berselemy. So what are the innovation knowledge when it comes to nuclear power? Can you share more your insights on this?
Absolutely. Thank you very much for the question. Indeed, we see a great pipeline of new wave of nuclear innovation that is nearing commercial deployment. And in particular, what many of you would have heard, so-called small modular reactors that other presenters have discussed, alongside Gen 4 reactors that use different coolant and moderators and can often operate with higher temperatures. I would maybe take the opportunity to stress one point with these new technologies, is that the analysis we conducted at NEA shows that in many cases, these new technologies, due to the technical features of this reactor, due to the size of the reactors, can address new markets, new applications of nuclear energy, in particular the non-electric applications, where otherwise large-scale nuclear power plants will not be a suitable solution. So it's a new wave of innovation in nuclear with new technologies and new applications.
好，谢谢。还有一个问题，还有一个问题要问您，是吧？您在演讲中提到。
Thank you very much. So you have another question. So you talked about how people overestimate the role of communication. So would you explain a little bit on that?
Thank you again for the question. I didn't totally grasp the question, which I did in the chat. So I'm struggling a little bit to answer, but I can still provide a few remarks, which are, I think, one point I wanted to convey is that when we are discussing the role of nuclear in pathways to net zero, we often struggle to communicate what nuclear can do toward meeting climate challenge. And in particular, what we see is we struggle to show that nuclear can do more than just large-scale new build and can really provide a lot of new opportunities for meeting energy challenges, and in particular also to support integration of viable renewables. So, one of the points we try to underline in our work at NEA is that we see a lot of complementarities among nuclear technologies and between nuclear and viable renewables, and I hope that somehow address some of the points in that question. Thank you.
好，谢谢您的回答啊。
Thank you very much. I have another question to Mr. Yasuroka. So one of the biggest challenges comes from the local community. So what roles can MITI take to restart the construction, to restart these projects, and how can we enable approval of the construction of the advanced reactors or Japan's three new builds projects that was suspended in 2011?
Yes, thank you so much for your question. I will just let this question in my from iPad. Yes, I think the word of the impediment is not the exact right words because so just 11 years ago, so Fukushima Daiichi had a severe accident. So I understand it's has a difficulty to getting light public acceptance, especially for the local stakeholders. So then I think this is not the silver bullet. So MITI's role is to give a good public communications to steadily and sincerely explain the benefit and risk and of the nuclear power plant, especially for the nuclear advanced reactors, and to restarting the existing nuclear power plant. So this may not taken by the MITI, but the utility or regulatory body, Japanese regulatory body called NRA, has a more severe and tightest, very high level of the safety new additional regulations for safety after the Fukushima accident. Lessons learned of this. So then the regulatory body has to pay a role of themselves, and also MITI is have to sincerely provide explanation for the advanced reactor and to the existing nuclear power plant based on its safety. Thank you so much.
好，谢谢。下面的话呢，这个田林
Thank you very much. Two questions to Mr. Tianlin. One is, could you say a few words about the Yanjiang? What's the plan for Unit 1 and Unit 2? Do you have follow-on plans for this project? What technology will be using? Another is for CAP 1400. What is the progress, and when will they be put into operation? And what locations will you be building new CAP 1400? Mr. Tian?
Thank you for your question. As to the first question, it's related to it's related to Lianjiang power plant. So yesterday, 2 units has been approved by government, and as planned, we will come to the FCD. The first concrete day is the June 30 next year. So for the following up units of Lianjiang, we will construct maybe CAP 1400 will be an option. So for the second question is related to the construction progress of CAP 1400, and at the end of this year, we will come to the point of hydraulic test. And we hope at the end of next year, CAP 1400 will come to commission. And for the following CAP 1400, we plan to construct the units in Shandong, including Laiyang, a new site. But it depends on the government policy and also on the preparation of our work. So thank you.
这就是想问您一下，现在的话呢
Well, actually, this question is about the 4 nuclear technologies which can replace coal. 3 of them are related to MSRs. The question is about the R&D of these 3 types of SMRs.
Okay, I understand. Yes. So yeah, we identified these 3 categories, and yeah, and all the organizations that are working on future reactors. There's always these timelines that they will become available from 2025 or 2030, or so I will refrain from doing that because it's all the time shifting. But you can already indicate some some features of these categories that will make it more or less probable that they will be able to contribute to climate change mitigation sooner or later. So whereas the water-cooled small modular reactors, they're benefiting from the current regulatory experience for the large water-cooled reactors, and also from the large experience base on materials and components manufacturing. So they will be available much sooner than the more advanced, the small modular reactors with other types of coolants. Although it's sometimes stated by those companies that are designing that they are also available very soon, but we can say that this category is has much larger chances to be available in the coming 10 years than the others. Then there's this category of the gas-cooled and the sodium-cooled, as there is also experience already with this type of reactors, and even there are a few operating around the world. And we can also indicate that there's a good ground that these will be available also sooner than those in the last category of the molten salt and the lead-cooled reactors that have much less experience. And this experience also means that there's a significant development to be done in materials. Materials development would also require irradiation experiments, which is also taking a lot of time, even assuming that the funding is available to do such work. So this is therefore I put in my in the graph this order of these 4 categories in order of their technological readiness and matureness. Thank you very much.
谢谢何友女士啊。
Thank you, Madam He. Also, in our Q&A section, there's another question which didn't identify the experts to answer. So this question is, how can we better coordinate the regulators among different countries? So who can you answer this question? Who can? So maybe Mr.
就是安良。
Maybe Mr. Satoru
Yes, this is 我是安良武谢谢。Yes, communication with regulatory body is a very key issues, and maybe we Japan have a special context because we experienced the Fukushima Daiichi accident in 2011. Just after that, as you may know, so our regulatory body is strictly independent from a nuclear promoting agency like METI or ANRI, or also there's a the distance to the strict distance to the electricity utility. But this is, of course, this is a rule, but we have the professional communication with the regulatory body, especially for the considering of the new next generations plant, because for example, in the advanced reactors like SMR or high temperature gas cooled reactor, utilities or like JAEA's TSO has the good communication, technical communication with the regulatory body because it needs establish a new types of the ideas of the regulatory system in the law. So then the like now, there is no specific reactors conceptual design from utilities vendors. But for example, so JAEA already promoted and developed HTGR. And just coincidentally enough, just 1 year before the 2011 Fukushima accident, HTGR has already experienced kind of the experimental test to using a test plant, and test is so how can I say to simulate kind of the loss of the coolant of the reactors, but the high temperature gas cooled reactors show the no serious problem, no accidental situation. So then the Japanese regulatory body admits that result of this. So then it makes the JAEA and regulatory bodies communication smooth. So this is, I think, a good example. So then my conclusion is neither, of course, keep appropriate distance and respect independency of the regulatory body, but we need to professional communication, technical communication to build up a new regulatory rules. Thank you so much. This is my answer.
好，非常感谢安良先生哈，您的
Thank you very much, Mr. Yaso Lauga. And also, I have a question asked maybe by some of you. I want to give you my answer. Well, yesterday, actually, the State Council of the Chinese government approved 4 units. That means in this year, we have approved 10 units of nuclear power. So in China, we have decided a guideline for developing nuclear security, the first thing, and we should enjoy a stable development of it. This year, we approved 10 units, which is more than the expectations and the plans. However, you see, in the last 2 years, we didn't have any new projects approved. Some of the projects would have been approved. So 10 is not a big number. And then this year, I don't think there will be new projects approved. Another question is related to CAP 1000. Why you approved CAP 1000 after so many years? I want to give you some explanations. You see, the Chinese government introduced AP 1000. At that time, in the industry, there were different ideas because AP 1000 was innovative. Its design in the whole world was unprecedented. So if you have a unit in China, that would be the first one. And our experts said that we should be very, very cautious to build the first unit in China. Different experts have different ideas. Some who were aggressive said that if we can have the first unit of AP 1000, then we can follow up. But others said differently. They said that after building the first unit, then after you have 3 rounds of refueling, and then you should approve new AP1000 units. So now the situation is the 4 units of AP1000 were put into operation. They have good records in performance, and the system was very much simplified. And then I think next year, we will finish the first round of refueling. And then we think that to some extent, we are certain that we can follow up, we can approve more projects of AP1000. That is my explanation. Thank you. So I think today we have finished all your questions. That's very good. Now we want to come to the conclusion of the conference. So Kakudo-san, do you want to conclude this conference? Thank you.
Yes, thank you, Mr. Quinn. And just remaining time is very short, so just briefly, I'd like to thank once again our panelists for their very insightful presentations and discussions for this webinar at the time when they are very busy. I'd also like to thank the panelists for their hard work in preparing their presentations in advance of the webinar. And I'd like to thank everyone who watched the webinar, especially those who commented and asked questions. Actually, the Q&A sessions are very active discussion we have. I also would like to appreciate the IFNEC Secretariat and everyone who worked hard to organize this webinar, especially our Chinese colleagues for proposing this very important webinar. Thank you very much. Today, we have learned a lot about opportunities and challenges of nuclear energy. And we hope that this webinar provided participants with insights and opinions on nuclear energy for carbon neutrality, and it helps to expand possibilities of nuclear energies and solve its challenges. Thank you again for your participation today. Thank you very much.
好，这个我跟
Okay. Also, I share your idea. I want to thank all the colleagues here. Thank you for your participation, and this is the end of today's webinar. Thank you. Bye-bye.